this recording goes to the cloud. Hey, everybody, welcome. Good morning, good afternoon, good evening. We are going to be entertained, educated. Olivier has done this session at least twice, right? I think for us, but he updates his slides. He finds new historical information, which is, that's what happens with research, right? Or another revisionist history. But I'm going to turn it over to you. You have your slides. We'll monitor the questions. So would you like the questions at the end, or do you want people to interrupt you and ask questions throughout? It's up to you.
Yeah, thanks very much, Glenn. Olivier speaking. I think we can have the questions at the end. I'll try and be efficient with going through the slides. In fact, the last time it was presented at VSIG, I think I was I had a conflict at the very last minute. Something happened, and you, Glenn, were the person who presented the slides. So we'll see. I don't know if that was recorded, but I hope I can do well to live up to that standard. In any case, thanks for inviting me to come over. And I'm going to have to share my screen, I think is the first thing that one does when one has slides. I have indeed made this presentation a number of times in a number of fora. Oh, good. This is exactly what I try to avoid, getting called by Skype. I've done this a number of times, and indeed, I am really excited because I've added a few more things because internet governance keeps on moving as it always does. If you have any questions, I'll be happy to take them at the end. So, but let's start with the 5 waves of internet governance. So these are the different moments at which the internet has evolved. The first wave was to do with the Defense Advanced Research Projects Agency, DARPA, and they came out with a lot of money that they received in order to create some kind of a military network that would be part of the response to the Russians having put Sputnik, the first satellite, in space. They wanted to do 2 things. One, to have some global network for their military forces. And the second thing they wanted to do was to also have, by the end of the decade, in that famous speech, someone on the moon. And they managed to do the 2 very closely. We'll see in a second. Putting someone on the moon was pretty hard. Putting together that network, globally was pretty hard as well, given the technology that they had at the time. The next wave after that was academic, when more and more colleges and research institutions went on the internet to help out with the development of the internet so that it reaches more computers and more people worldwide, and also with the advent of TCP/IP that we'll speak in a second. The next one was commercial. That started in the 90s. That's when you've got the World Wide Web that came up. And that completely dramatically changed the situation from something that was used by geeks and scientists and that didn't need pictures and didn't need video and didn't need all the music and stuff, to something that could be exploited commercially and selling you things. After that, mass media, that's when video really took off because the speed at which you could receive internet at home became fast enough. And that started around the 2000s. This is also when you see the likes of YouTube and then Facebook also sharing videos. And of course, after that, you ended up with the other services like Instagram and Skype and Twitter and all these. And then the 5th wave from 2010 onwards was the whole concept of everybody and everything. Any business can go on the internet and would be affected by the internet. And that's where you got the growth of apps on mobile phones. This stuff, no longer really internet, but it's something running on your device that makes use of the internet behind. You've got 4G, so faster connectivity, 5G, which makes it even faster. Why do you even need to stay home when you work? You can do this from anywhere you want around the world. And of course, the Internet of Things, another thing that changed the internet radically from being just a network that supports people to a network that actually supports machines, etc., all sorts. So let's have a look now at the first history of the net. And then after that, we'll look into the geopolitics of it and the various organizations that are parts of it and that make it work. So as I said, the internet technology was developed in the 60s. The technical specifications run from the Internet Engineering Task Force. It's been like that since the early days. And the development of those standards is, I guess, multi-stakeholder in scope, in that anybody can come in and take part in this. Anybody with the right qualifications, of course, can go into that. There's no single owner of the internet. It's a network of networks. So your internet service provider controls their little part of their internet with their customers, but then there's another internet service provider somewhere else. And there are some service providers that will deal with what we call the backbone, the big pipes that go around the world, the interconnections between continents, etc. And there's this whole way of them to work with each other so that your traffic gets carried by others and the traffic of other people gets carried over by your provider, thus being able to have end-to-end communication. It's had this domain name system since the 1980s, a system by which you don't need to remember IP addresses, suites of numbers. You can actually write a name in the browser that you're using or send an email with a domain name. And all of that works because there is a single root. It's like a whole pyramid of names that come together. You type the name and the whole system is fully distributed around the world. So it doesn't crash, it doesn't break down completely. We'll see that in a moment, but it's quite a clever way to do things. So this is how the whole thing started, with self-management of the internet. The first node was in September 1969. So you remember this whole thing, that the Americans put someone on the moon in July, and then a couple of months later, the internet, the first ARPANET connectivity took place. That was very, very last minute, but it grew very quickly, so that by December, you had a lot more nodes that were connected together. And this was all based on a system called packet switching, a system that Leonard Kleinrock had developed along with JCR Licklider during that decade. The whole concept that you would cut information up into digital packets and then send them in different order through the system, and they would reassemble themselves at the other end. Of course, all of these things, documents that started coming out with standards and so on, required some kind of classification. And Steve Crocker, one of the scientists who was involved at the time, thought that perhaps we could call these requests for comments, because at the time people were publishing a paper and saying, well, this is how we think that we can have a file transfer from one computer to another computer, and this is how we think it can be done. We request comments. We ask for people to comment on this, and is that possible? Is that not possible? Are we going to go forward with it? Are we not? And slowly but surely, from RFC number 1, the request for comments continued, and now the Internet Engineering Task Force has reached, with 8,000, 9,000 RFCs. I think he'll soon reach 10,000 RFCs, and they are the standards of the internet. They're not mandatory, but if you're going to provide a service or provide some system that works on the internet, you might as well adhere to those standards, because it's the only way your system will work with the other systems out there. And this is really one of the things of this open nature of the internet, where you say, well, I've got something new, but it's really your willingness to adhere to those standards that makes sure that your services, your system are going to be able to work with the rest of the net. Sure enough, in 1971, you can see things grew a lot faster. More nodes getting connected, to the point that the first protocol that they were using at the time, NCP, Network Control Protocol, was no longer possible for an efficient transfer of communication. There were limitations to it. And this is when Bob Kahn, who was working at Bolt Beranek Newman, and a guy called Vince Cerf, who was a graduate student at Stanford University, worked together to come up with this TCP/IP, Transfer Control Protocol, Internet Protocol. And that is a game changer. In fact, that's what gave the name to these two gentlemen as being the fathers of the internet, because to this date, the protocol that is used by the network for computers and devices and routers and everything to work together uses this TCP/IP. And they did rather well in designing it, since it served us until this day, and it served us rather well. As time went on, more and more computers got connected, and this is where you started seeing networks. So originally it was just machines, but then of course, Stanford had one machine, and then two, and then 10, and then 20, and then they had their network connected. And this is where you ended up with so many interconnected networks, things started to self-order themselves. Why? Because the military, who were the originators into this, were on the same network as the academic community. So you had universities on there, you had a few commercial organizations. And as you know, when you have students and you have military, you have this whole fantasia, this wonderful thing of thinking, hey, let's play global thermonuclear war. Wait a minute, I think there was a film about this. Anyway, the whole point was that the military network started getting hacked by some young, clever people that found ways to hack them and to do things, and therefore they started partitioning the networks. Now it's not really called some kind of a breakdown, if you want, because they were still connected with each other with gateways, but there was, of course, a much higher level of security in the military network, MILNet, than there was perhaps on the ARPANET, or a different level of security that there would be in the wideband network, which were some newly thought of radio networks. And then SATNet was one of those networks that actually started working, interconnecting parts of the net by satellite. This is, in fact, it's SATNet that connected the first nodes outside the United States into Europe, into the UK, and into Scandinavia as well. And you can see how this all grew. And soon enough, the second problem arrived, which was the naming problem. Because, okay, so they had the DNS. They didn't have a DNS. They had a system, a table, by which you would have a name on one side and you would have an IP address on the other side. And they would all be a name.arpa, because it was the ARPANET, so something.arpa. So let's say VSIG.arpa. But of course, as more and more people went on to the internet, there was a requirement to have more names being used. And that table, which was sent every day to all the computers that were connected, and that would allow for people to type the name instead of remembering the IP address, that table started growing very quickly. And so the person who was updating those, poor sod, started having a workload of stuff to update every day, that it was no longer possible to update these things manually. This is where they thought about it and said, right, we have to come up with a new system, a distributed system called the domain name system. And this is where you would have a root server at the top that would just be updated with the pointers to the different top-level domains. So you'd have the first ones that were introduced were MIL, for military, gov for the government, com for commercial, net for networks, org for other organizations, and edu for educational institutions. These were the first top-level domains in 1985. And at the same time, the DNS was also introduced, so that you would have this distribution of the updating. So the government servers would be in charge of updating all the government sites. And then a commercial, you'd have a registry that would be updating all the commercial sites. And then for the network, it'd be something else. And so you end up with a system by which you have this distribution of power among many different actors. At the same time, the internet continued to grow very quickly. The military, as I said, separated on one side. MCI, a company that, hey, Windsurf was working with, started commercial email service on the internet. And also the rest of the internet was still pretty much paid for by the US taxpayer, because, all this research, all the academic institutions were on this network doing research, and that was paid for by the US government. And from 80,000 nodes in January 1989, it reached 160,000 nodes in November. So you're looking at a doubling of the size of the internet. But you ain't seen nothing yet, because things went even faster when some commercial organizations decided, let's offer commercial services, proper commercial services. Now, MCI is offering email. We're going to offer full internet connectivity. And so PSI, UUNet, and ANS Core, I always call it Core, I don't know, CO plus RE, whatever. These guys decided to create their own commercial services that was going to be interconnected with other services through peering agreements. So an agreement where I carry your traffic, you carry my traffic. We carry NSFNet traffic, and the NSFNet can carry our traffic. The NSFNet was the National Science Foundation Network. That's the organization that started funding all of the educational networks in the US, because, of course, more people, more services meant a lot more bandwidth required. And they ended up having acceptable use policies, which was effectively, if you're a commercial organization and you are on the NSFNet, you need to find yourself a new home, because we no longer carry commercial traffic. This is where things, again, reorganize themselves pretty quickly. Of course, having this network on one side that was commercial, and then this other network that was non-commercial, and then the military network, meant that you needed some kind of interconnection point. And this is where the Commercial Internet Exchange was created in 1991. And it got the signatories to sign to all connect in a single connection point and carry each other's traffic. It was a neutral exchange point. And this is what really now established the concept of the Internet Exchange Service Providers, the IXPs, that you have throughout the world, where if you have two internet service providers in a country, instead of both of them being connected to the outside world and then traffic going outside and coming back in, if they have a neutral local internet exchange point, they could actually connect to each other locally and connect to all of the other ones. And they could save on long distance bandwidth if they needed to. In 1991, the internet services only consisted of email, FTP, a system called Gopher, and we'll look at it in a moment, wide area information servers, WAIS, Archie, which was another text-based thing, and then Telnet, which was to connect to a remote host. All of that was text-based. And suddenly, well, first we can see the Gopher. And you can see that the Gopher had this advantage. So you would navigate this not with a mouse. That was still not really, very few machines had mice at the time. No, you needed to use your up and down arrows, or you could type the number that you wanted. So if you're fast enough, you can type 1 and 0, and the thing would jump over to 10. And you would be able to look through the sub-pages in a site. So there was some kind of an arrangement with this, and you could actually even download pictures with this. But the whole navigation was still very textually based. And then a guy called Tim Berners-Lee, over at the CERN, the European Center for Nuclear Research, thought, well, using this system with arrows and so on is really difficult, because a lot of our work involves sharing of information that has got video, that has got graphics. We need to be able to share graphs and things. We need something better than that. And he, with a few colleagues, developed this language that a browser could use to actually order the pictures and order the text and order any video and anything else onto a page that looks good. And this is where HTML was born. PCs, the personal computers at the time, became more powerful, so they could handle computer graphics. Microsoft released another version of Windows that was better than the previous one, that wouldn't crash, wouldn't give you the blue screen of death every 5 minutes. Remember those early days? Oh, yeah. Oh, it's crashed again. No, things were getting better. Apple, of course, had come up with some other versions of the Macintosh. Things became a lot better. And so at the same time, the University of Illinois Urbana-Champaign, looking at this HTML, said a group of students said we can put together a browser for this, and we're going to call it NCSA Mosaic. Now that was the first real free browser given out. It was a summer placement summer project, and they said just download it by FTP and then install it on your machine, and you'll be able to use the web. What a difference! And that's the kind of web that you would see. I hope that you can see it well, because let me just move this a little bit aside. Hopefully you can see the full screen. That was the first IBM web page. That's a picture I took myself back in the day, and using NCSA Mosaic. Yes, it's in black and white. Well, you know, we at the time, it wasn't even black and white. It was black and orange or black and green. And it wasn't great. It was available in color a little bit later on, but you see very grainy pictures, and, you know, not that wonderful, but so different from having something just in you know, in text mode. And then, of course, the moment you ended up with the browser, a free browser, a commercial browser came up, because those guys that had graduated from the University of Illinois at Urbana-Champaign thought, hey, let's start a little company ourselves. And they called it Netscape, and that was the first commercial web browser. At the same time, if you can start consuming information much faster than you could before, they thought, how in the world are we going to find this information? And there were two ways around it. The first way was to have some kind of a spider that would crawl around the web and make copies, and you know, make copies of all those pages and find out where they are, and then put them into some kind of a search engine. And that was what Web Crawler was about. That was created in April '94. And then there's two guys, David Fallow and Jerry Yang, who were also in California in '95, thought, no, that's rubbish. We don't believe in this machine stuff. We're going to employ students to actually put together some kind of a directory of websites. And that's when they created Yahoo. In '95 also, Microsoft released the Internet Explorer. So there was a native Microsoft product for Windows. Alta Vista, another search engine, was created in '95 as well. There was a company called DEC at the time, which is Digital Equipment Corporation. They were a manufacturer of big backbone, big machines, you know. And so they thought, we can use these to crawl the web faster and have more information into our system. And in the UK, there was also a search engine called Ask Jeeves in '96. And it's only in 1998, so quite a few years down the line, that Google came up. And what was the difference between Google from all the others was that the others were just taking care of sucking all of the internet. And if you were doing a search and you'd say, I want to find out about sparkling water, let's say, it would give you in no order the sparkling water things. And in fact, it would put at the beginning the results which had the most links. Links to it and links from it. So the way that people would do to actually get their internet page up ahead of everyone else was to just create 4 pages or 5 pages, several pages, and connect them with each other. And hey, we end up at the top of the search engine. Well, that wasn't very good as far as searching things. And Google came up with some much more clever algorithms so that, miracle, you would search for something and you would actually get the information you wanted. So they grew very, very quickly indeed. It's only in 2005 when the technology improved, and as far as bit rates and the speed at which people connected to the internet, that YouTube started. It started as its own company, and it was very quickly purchased by Google, who by that time were already absolutely huge, because they pretty much wiped off. Web crawler no longer existed. Alta Vista died as well, and Yahoo as well sort of was pushed to the side, and Google was the big firm out there that took over. As far as connection of the internet was concerned, things really moved very quickly from the mid-90s onwards. I've got here a picture of Asia. On the Americas, if you look at North and Latin America, the picture is somehow a bit different, because a lot of countries were connected very early on. As far as Asia is concerned, you see there were a lot of countries that still were not connected. What's in this wonderful color, yellow and red cross, which, by the way, remember, this was meant for the monochrome displays of the time, so you could see the difference between one and the other. If I had colored one yellow and colored the other one green, it would look the same on the monochrome monitors. So that's why it was it was like that. You can see in 93, China was still just using this telephone service called UUCP. It just was email. And a lot of the other countries were like that. And the countries that didn't have any coloring did not have any internet connection at all. And you just go a few years later and you find out that the great majority of countries around that region had very good internet or pretty reasonably good internet connectivity. If you look at a network map from the late 90s, you can see that some connections took place by satellite. So for example, if you look over the Pacific Ocean, Australia, being extremely far from the US, had a set of satellite connections with several satellites. On the other hand, there were some cables between Asia and North America, and there were also a lot of cables that were laid in those years between North America and Europe. Also, some cables going over to Latin America. I remember the first one that started connecting the Caribbean and Latin America was one that a cable by, I think it was Cable and Wireless, that came over to Anguilla at the time. And wow, what a revolution. Suddenly the whole area had the potential for amazing internet connectivity. One of the things that made the internet so special and gave it the ability to grow so quickly was this end user principle. You know, in the 70s and 60s, telecommunication companies had a monopoly over running their networks. And in order for you to either propose a service or connect a new device to it, you needed to go a very lengthy process by which you would need to perhaps send a version of your product to the telecommunication company, and they would look at it and they would take it apart and they would ask you for a certain amount of money for them to evaluate it, see if it works on the network, etc. And it might take a year, more than a year, maybe 2 years for this to actually be implemented and for this to be allowed on the networks that they were operating. But with the internet, there was no longer such a thing. There was telecom deregulation going on in all sorts of places all around the world. And if you had an idea for a service or something, you would get your connectivity to the internet, and then there was no filtering. You could just put it out there and, you know, the best ones would win. If you had a website that people liked, there'd be a lot of people going on it. If you had a new service like a voice over internet protocol, like Skype, for example, then you would implement it. People would download it on their machines, and soon enough, they'll start using it. So the smallest startup company could become very successful worldwide. And we saw that with all these startups that became absolutely huge so quickly. With this came this whole thing of how are we going to govern this darn thing? Because obviously you've got now all these commercial people trying to make a quick buck, trying to make some money out of this. But how are we going to govern it? Are we going to have some kind of a charter or something? And so the United Nations had some working group on internet governance, WIGIG, that started looking at this whole internet thing that was revolutionizing the world and came up with a definition which is as follows. Internet governance is the development and application by governments, the private sector, and civil society in their respective roles of shared principles, norms, rules, decision-making procedures, and programs that shape the evolution and use of the internet. Why did I take the time to read through this in this terribly cumbersome way? Because that is extremely important. That is one of the, I guess, the governance principles by which the internet has managed to continue to grow. The point that it is multi-stakeholder in scope when it comes down to the governance. It's not just governments that are in charge or the private sector that are in charge or civil society. It's everyone working together to share those principles, to share the technology, to share the norms, the rules, everything, and actually grow this step by step and continue to allow it to be this extraordinary vector for innovation that we have seen today. And not only just vector for innovation, but vector for democracy as well, which is one of the topics that I think is often being discussed in those internet governance fora, etc. There are also so many organizations. This is a graphic from a long time ago that the Internet Society had put together, showing the number of organizations that are working together in these in this whole internet governance principles, and between the users and the open standards being developed on one side, and then all of the naming and addressing around ICANN, and then of course you've got these whole internet governance forum that we will be speaking in a moment. It's a really interesting thing, and in fact, the internet being what it is, and internet governance being what it is, it's like a building site. Diplo did this really cool diagram that you can see here with, on the one side, you've got this whole thing under construction with like lots and lots of organization working pretty crazily together. And then you've got all these different floors with the different aspects of the internet, from the human rights aspect to the economic aspect to the legal aspect, and of course the socio-cultural aspect, the fact that the internet has revolutionized the world in our everyday lives. So let's have a look at a few key organizations. And the first one is the Internet Society. Why the first one? Because that was really the first organization that was purposely built in order to act as the legal home of the Internet Engineering Task Force. It was founded in 1992, which is pretty late in the game, but it was Vint Cerf, again, who was one of the main people that put it together, along with some of the big because there's not just one father, many of the fathers of the internet and mothers of the internet as well that put this organization together. And it was to basically provide some leadership in anything that's internet related. And one of the things that it was saying was the internet is for everyone. Now, this is a big statement back in 1992, when only a few 100,000 people were using the internet. Nowadays, of course, we look back and we think, okay, well, it's still more than half, well, perhaps about half of the world's population still doesn't have access to a good internet, or maybe even to the internet at all. So this vision is still very much in place and very much current. There are chapters of the Internet Society around the world. You can see they're sprinkled a little bit everywhere. And the Internet Society is the home, or was the home. Now it's changed a little bit, but it still supports the Internet Architecture Board on one side and the Internet Engineering Task Force on the other side. So here you have the whole standards making process. And I invite you to consult the websites of these respective organizations to find out what they do and how to get involved with them. If you are an engineer or a technologist and someone who is interested with internet standards, these are the organizations that you should go and visit. And you can work, everything is open, the work is open, you can get involved with them directly. ICANN is another organization that is open for everyone to take part in. It's the Internet Corporation for Assigned Names and Numbers, and that was the organization, the commercial organization that was developed to take over the registry services that the US military were assuming all the way until 1998. The story goes, as usual, that someone in the Congress made a study of how much did it cost the military to run this new DNS, domain name system, and to update those tables that needed to be updated for the top level domains. And of course, they came up with a number, they published this, they said, that's outrageous. This is US taxpayers, and there are these foreigners that are benefiting from this. This thing needs, something needs to be done. And so this is where there was this proposal that was made in the US. Now, there were rival proposals also that were made by the Internet Society and the ITU and so on, to perhaps have something based in Geneva that would assume these the running of the domain name system. But ultimately, I guess the ICANN won because it was US based to start with. And it took took over the functions with the green light of the US government. The interesting thing about this is that the policy making is multi-stakeholder, is bottom-up, and is consensus-based as well. And that's really what's also managed to make it work. When I talk about top level, by the way, in a domain name, I'm looking at the top things. So as I said earlier, you know, .edu, .org, .com, .net, but also .uk, .cl, .us for some of the sites in the US, .de, .cn for China. The country code top level domains are equally as important. And all of that is coordinated over in ICANN. And then you've got the root servers and the regional internet registries. I mentioned to you the domain name system. And so it's a hierarchical system that is used by the web, by emails, other services. And at the top of that pyramid are the root servers. And so there are 13 of them that are located around the world. And you can see them here. And you can see that historically, it looks like most of them are based over in the US. And there are only a handful of them outside the United States. And this is why a system was developed by which there are copies, local instances of these root servers. And this is the latest that I've uploaded a couple of days ago. You can see that there are hundreds and hundreds of instances of the root server around the world. The main root server, the master root server, the first one is the A root that is uploaded from ICANN through the INS services. There's the Internet Assigned Numbers Authority, and it transfers over every, I don't know, at least every day or maybe twice a day or something, transfers that over to the A root server, and then it gets automatically spread worldwide. It's an extremely reliable system. It's never broken down. You know, you're looking here at 868 instances of that system. Even if you try and pull it down, you need a heck of a lot of power worldwide, because you can see now it's really all around the world. Now, the regional internet registries are another form of organization that deals with the sharing of the IP addresses. You know, so the numbers. Every computer that is connected on the internet needs to have an IP address, and so the regional internet registries distribute them worldwide. You can see the different regions, and in fact here you can see how the regions are coordinated. Each part of the world had its own network information center that deals with it. Then you've got the World Wide Web Consortium, of course, that deals with the browsers. They actually, so it was led by the web inventor Tim Berners-Lee. They have a new CEO called Seth Dobbs. Previously, Jeffrey Jaff was around for quite some time, and they developed the World Wide Web Consortium's, the web principles and standards, because as you know, the web from back in those days is very different from what it is today, and there are always new services that are available on websites, etc. Now, the ITU, the International Telecommunications Union, is an organization that's been around for a very long time. As you can see, it was created in the 1860s, and it started by regulating telephone services. In fact, it's got a whole number of sub-organizations underneath it. It somehow missed the internet game, but it's still very much, well, very influential, in fact, key to the radio allocation for the radio regulations. And if you're using Wi-Fi, by the way, then the coordination of, you know, being able to use Wi-Fi in one country or another country, and it's the same Wi-Fi bands and so on, is very much regulated by the ITU. It had in 2012 a World Conference on International Telecommunications, which somehow looked at trying to regulate the internet. That failed, and there's not been another WCIT ever since 2012. It also has the World Telecommunication Policy Forum. The last one was in 2021. The next one will be in 2026. There's also the WTDC, World Telecommunication Development Conference. The last one took place in Kigali in 2022. And the next one was supposed to take place in Thailand in, I think it was this year, this or next year, maybe next year. There was a problem with it. So now the next one has just been announced is going to be in Baku, Azerbaijan. And they look at a strategy and objectives for the development of telecommunications on a wider scale. That also includes the development of satellite links, et cetera, et cetera. They've got a plenty pot going on every number of years as well. The next one is going to be in, well, the last one was in Bucharest. I don't know where the next one is. I don't think it's been announced yet, if anybody knows, but I did check and I couldn't find it yet. And that's all of what they're doing. There are quite a number of United Nations processes. There's the Internet Governance Forum. We'll speak about it in a moment. There is the CSTD, Commission on Science and Technology for Development. That's based in Geneva. It's part of the UN UNCTAD, which is UN Council for Technological Advance and Development, something like that. It's all about development on a wider scale, not only just for the internet, but development of countries worldwide. UNESCO is based in Paris. There's the UN General Assembly based in New York. And of course, the UN are the organization that organized that World Summit on Information Society in Tunis back in 2005, what we call the WSIS. There is a process which then took place 10 years later called the WSIS plus 10, and it looked at the Tunis agenda, which gave rise to the Internet Governance Forum and to many of the fora that we have today as far as Internet governance is concerned. And next year, we have the WSIS plus 20. 20 years since the signature of the Tunis agenda. A lot of things going on at the moment, a lot of discussions going on as to where we will go at that point. Are we going to continue with the same direction, or are we going to change the direction? The Internet Governance Forum is one of those multi-stakeholder platforms and fora that takes place once a year. There's a lot of inter-year work going on as well. And the next one is going to take place in Saudi Arabia. And it's a place where people discuss internet governance. There's no real decision being made there, but often decisions get made elsewhere, but the originating location for the discussions and for the issues to be put on the table and discussed at pretty high level are at the IGF. Anyone can submit a workshop proposal, and then the advisory group, a multi-stakeholder advisory group, chooses and puts together an agenda out of it. As I said, the next one is taking place in December in Saudi Arabia. There are a lot of local and regional internet governance fora taking place as well. This is from a few years ago. You can see they're scattered around the world. I really encourage you to have a look and try and find out if you have a regional IGF in your part of the world and take part in it. There are also some youth IGFs, young people that will take part in this. And all of the work of these regional, national, and youth IGFs get fed into the overall Internet Governance Network system, Annual Internet Governance Forum. The big new kid on the block, should we say, is this thing called the Summit of the Future. That was something that was launched about a year and a half ago by the United Nations in New York. And as you can see, it's very current. The 20th and 21st of September were the action days, and yesterday and today are the summit days. And it's a high-level event that brought together the world leaders. It's government-led, and the world leaders convened to create three things: a pact for the future, which has global digital compact, and a declaration for future generations as annexes. There was an amendment that was filed 2 days ago. That amendment was filed by the world's best democracies. Did I just say that? That included Russia, North Korea, Iran, and a few other friendly places. That was voted down. And so we have just read this morning, there is a Global Digital Compact document that has been done, and that reinforces the point that internet governance is multi-stakeholder, has a multi-stakeholder aspect to it. And so this is an ongoing thing, and it's just hot off the press at the moment. I've just spoken about multilateral and multi-stakeholder. What's the difference? Well, multilateral, a multi-stakeholder is where you've got governments, businesses, civil society, individual users, everybody basically able to take the decision together in consultation and using consensus most of the time, or for as much as possible. Multilateral is a system by which governments speak to governments, businesses speak to businesses, civil society speaks to civil society, but ultimately governments make the final decisions. They may ask for advice from other stakeholders, but they are the ones that make the decisions. On the internet, we really are pushing for a multi-stakeholder way of doing things, because early engagement of all the actors makes it something that is recognized. It engages everybody in the discussion from very early time. The only difficulty, sometimes it's very difficult to reach consensus. And sometimes it has a tendency to be a bit theoretical. So, as you know, in theory, practice is the same as theory, but in practice it isn't. And there's always this problem of how in practice do you fund all the stakeholders to be at the table, or do you have this sort of second-tier stakeholders, the one that are far away and following remotely and so on? It's a real challenge. And challenges there are on the internet. There's a fragmentation challenge of the internet that could break apart for so many ways, maybe because some countries no longer want to be part of this global network of networks because it affects them negatively on a political level, or maybe because some companies, some organizations want to run their own networks and their own protocols that are going to be different. There's regulation on so many levels by so many governments that going on at the moment, all to do, or mostly to do with control, where they think that, oh, we need to control this internet. There's the whole point about encryption, where encrypted traffic cannot be checked by third parties. And so that could actually help with child sexual abuse material, with terrorism, with a whole lot of bad things taking place. So there's, again, this struggle going on about, should we allow encryption, should we not? Cybersecurity is extremely important. You will have seen in the news the reports of hackings going on, and data breaches where, you know, a database with millions of names and their phone numbers and sometimes credit card numbers, sometimes date of births and so on get lost or get hacked in some way. And there's also the whole problem of privacy. With your data being shared among so many organizations, sometimes organizations know more about you than you do know about you. And on top of that, technology keeps on evolving so fast that we end up with 5G, with the Internet of Things, which are always new abilities for things to break down and stop working, unfortunately. So we rely so much on this, and we have just so many challenges that are there. So I guess that with the 6 waves of internet governance, I've added a 6th one, which is the let's do something syndrome. It's a problem. It's a problem because you see now the internet's been around for quite a number of years, more than 50 years. And so it's going through this point of thinking, are we doing things right? Oh, but there are so many problems brought by the internet. You know, things were great before, now they're worse. And so many governments are now saying we have to do something about it. And that's where you start getting things that sometimes don't go down too well. One of them is the NIS2, the Revised Directive for the Security of Networks and Information Systems. It makes things more complex. It asks, it tries to make the internet more trustworthy, but at the same time, it introduces a whole number of regulations which make the entry point into being an internet service provider or into starting an internet business a lot harder. And that could have a negative impact on the nature of the internet being able to grow so much. And there are also governments that are focused on weakening encryption. We've seen recently the limitation of online services, you know, Twitter and X, in many countries, including the recent thing in Brazil, Telegram being blocked in other places, some services being blocked because they are a threat to national security. And it's got a huge implications to our everyday lives, because nowadays, since everything's moved onto the internet, whatever you do to the internet will actually also impact us on privacy, on freedom of speech, on the security of our transactions, on who we are, our online persona. So what needs to be done? Well, first thing, avoid breaking things. So when you think of new laws, new rules, new implementations, make sure that you're not going to break what already exists. Educate people, educate your members of parliament, educate politicians, educate non-technical people about how this whole internet works and how amazing it is, and it needs to be kept running as openly as possible, as distributed as possible. There are better tools for identification and security of transactions that are needed so that we don't end up all hacked and in real trouble. Continue implementing the next generation of the internet protocol, what's called IPv6. And then, of course, engage you and anybody that you know that has the ability to do so in multi-stakeholder governance processes. I know it's not for everyone, but the more end users we have that are involved in this, the less work there is for single people to deal with things, and the more likely it is that we will have a future internet that will be middle of the road rather than ending up in the hands of either a single set of governments that want to control our information and control us, or companies that want to just see us as cash cows, able to make money with everything that we are without really giving anything back. So that's, get involved as you can be. And I think I've spoken enough time. We have a few minutes for questions. I'm so happy to answer them.
Great. So I wanted to invite, we have a couple of minutes left. If you folks, we have a small group here today, but the recording will be shared with the rest of the group. The problem with VSIG is we have a bit of a challenge with people with different time zones, but they do catch up. So I just wanted to thank you so much for your
Glenn, we lost your audio.
It looks like we've lost Glenn McKnight. Has he been?
No, I think I was being censored. Yeah. What I'd like to ask to start off with, for the benefit of the students, there's a lot to pick up. What's your recommendation for them to dive into? What's the first thing they should be doing?
If you're, thanks, Dan, it's Olivier speaking. If you're technically minded, of course, engage in the Internet Engineering Task Force. Have a look at what they're doing. There's so many different groups that are working to implement further standards, refine the current standards that we have, etc. If you are interested in looking at a multi-stakeholder, an operational multi-stakeholder policy development process, then get involved in ICANN. For some, they say, oh, I'm not interested in domain names and so on. Yeah, well, the interesting thing about ICANN is the fact that you have an actual operational model by which all of the different players, including end users and the community, the professionals that make the internet run, actually have an open policy process, and your voice makes a difference. And you can relay the voice of the people around you in those processes. It's a steep learning curve. There's a lot to learn, but if you can get involved in this, you can start small and maybe just first follow what's going on. You'll see how fascinating it is that a multi-stakeholder system with not a single person saying we're going to go that way or that way or that way. You really learn a lot. That's a really great way. And then, of course, if you're interested in matters of human rights and the more socio-economic aspects, then get involved in organizations that are involved in the Internet Governance Forum. And that includes the Internet Society, that includes other organizations that are out there that will submit workshops and so on. Go to intgovforum.org and you'll see the different organizations and workshops that are available in the next IGF. The great thing is that you don't need to have a travel budget these days. You can follow everything remotely using remote participation. And in the past few years, ever since COVID, there's been a significant shift to treat online participants at least as well as the people that are in the room.
Right. Great. Thank you. I think we have a question from Bill.
Actually, a comment more than a question.
Okay.
I want to take issue with something I thought I heard Olivier say, which is that you don't, for the most part, need a qualification. Yes, there are various bits of organization where you have to be representing a government or you have to be representing a company that runs a particular top level domain. But if you want to get involved with ICANN, if you want to get involved with the IETF, the requirement is only show up. It really is just that open. Whether anybody will pay attention to you once you're there is another question, especially with the IETF. But for the most part, you can do what I did some years ago with ICANN and just walk in the door. And if you're willing to help with stuff, people will be more than willing to embrace you. You don't need to be technically knowledgeable. You can be somebody who just has an opinion about what the impact is going to be on end users. You can be somebody who's good at doing technical editing, because all these organizations put out documents. For the most part, they're appallingly badly written, in my humble opinion. So just somebody who could come through and help fix the things that are written so that someone who isn't deeply embedded already can understand them will be embraced with open arms. So there's all kinds of opportunities to get involved. Don't say to yourself, gee, I don't know anything. I just got out of school. Whatever. I'm not an engineer. I'm not technical. I'm not a lawyer, et cetera, et cetera. Walk in the door. We'll be happy to have you. Thank you.
Great. Any response, Olivier, to that?
Yeah, thanks, Glenn. Recently I've been toying around with various versions of AI, and I can tell you AI does help with improving the way you write documents. You can ask the AI engines, rewrite this crappy piece of text into something more legal, more formal, and it will actually do it, which is pretty impressive.
Indeed. I'd like to do a call out to James and Rukia. Both have been fellows with ICANN, and they're dedicated to be on this call today. It just shows you that, people who are interested in getting into this game, and, we have 77 people registered for this this session today, and it's incredibly valuable information, and we really appreciate your time, Olivier, for doing this. But you know what? You can take somebody to water like a horse, but you can't force it to drink. So I'd like to do a shout out to everybody that joined us today. You didn't do many changes on those slides, but I did notice a couple of things. Not to be picky, but I was at WSIS in 2003 in Geneva, where then they went to Tunis, and most of us in the civil society decided to not go to Tunis. So a lot of times when I read this stuff, and I saw it on your slide, that it's all started in Tunis. Well, there was a dedicated group, and I remember being in Geneva, and Richard Stallman of the free and open, well, he never says open, free software. And he got into a massive argument because the translator screwed up, because if you say open source and it's like swearing, saying his mother it was some kind of prostitute or something. He used to get really upset. You remember Richard, right? So but this is great.
Very vocal character, very vocal character.
Yeah, what's kind of funny, he was at the time, because I was with the Linux Professional Institute, and he was our nemesis. But as I gotten older, I'm sort of agreeing more and more on. I'm becoming more like Richard, so I'm becoming more radical in my views as I get older. But The last comment, Olivier, if you'd like to say anything.
No, I'll take notes. Yeah, indeed, the thing in 2005 was the summit itself was I guess the top of the hill for preparations that took many years before that. It's the same thing, you find out that TCP/IP being invented in 1974, but it was only implemented a year and a half later. Things take a time. And one thing that I do note, and it's really, really important, is that the internet is the internet, not because of the technologies, but because of the people that built it, the people that built its governance. It was always about people, and it will always have to be about people in the future. The day it will not be about people anymore, it will fail. There are millions of people, and I'm not chewing my words, millions of people who've put their little brick in the whole thing to build what we have today. And I think they should all pat themselves on the back for that.
Great final comments. Thank you so much for your time today. Pleasure. And I hope to see you for dinner when I see you in Turkey. And that concludes the call today. And I'll share the recording as well. Thanks, everybody. That concludes the call today. Thank you.